The first problem we have asks you for the domain of a function. So if we have a graph, then you're going to use the x-axis to see how wide it is. And you can see this arrow means it's going to keep going to the left forever. So it's going to keep going in this direction forever. So we're coming in from negative infinity until we get to 3, and there's a vertical asymptote at 3, and vertical asymptotes are never breached. So there'll never be a point on that graph with x coordinate 3. So you have to jump over it. But once you jump over it, you can see that it's going to keep going like that forever. So what I've drawn here in red is the domain. And now if you have it in interval form, if you read off what's in red from left to right, we're coming in from negative infinity, coming up to but not including 3, having to jump over 3, and then continue on forever. So the answer to number 1's A. Now going on to the next one. All right, if we have something like this, I'm going to copy this and put it somewhere else. Okay. So when you have a square root, and the square root is not the denominator of a rational expression, then your argument, what's inside, is greater than or equal to 0. So here we want x squared minus 2x over 8 to be greater than or equal to 0. You can factor out an x in the numerator, so you can see it equals 0. That in red. It equals 0 when x is 0 or x is 2. So when you have something like this, how can you tell when it's greater than or equal to 0? You look at the graph. And when the graph is on or above the x-axis. So we go here and we've got x squared minus 2x in the numerator and divided by 8. And if you start with a zoom 6, okay, you really can't tell what's going on here, so I'm going to adjust the window. I want to see the 0 and the 2 for the x values, and I'm really just going to take this from -1 to 1. So the graph of this is on the x-axis when x is 0 and when x is 2, and then it's above here. So if I read this off from left to right, from the left we're coming in from negative infinity, and then we go up to and include 0. And then there's a gap, and we pick it up again at 2, and 2 is included. And then we keep going forever. And so that's going to match with this one here. Okay, so notice that the bogus one, 0 and 2 are not included. And that's not true for this case. The argument is greater than or equal to 0. So it's D for that one. Now let's go back to the file. Okay, now what's important here is you've been asked for the range. And what a lot of students will do is they'll look at this and do the domain. Domain is how wide it is on the x-axis, so we start at -1 and keep going forever. So that is the domain. That is not what you've been asked for. So be very careful to read the question as to what you've been asked for. With the range, you use the y-axis to measure how tall. So from bottom to top. So I do have a lowest point here, and it corresponds to a y value of 0. And then this graph is going to keep going like this forever. It's going to keep increasing slowly, but it will keep increasing. So if I'm measuring from bottom to top, there's not going to be a top. Now, from bottom to top, in interval form, we are starting at and including 0. And then it keeps going on forever. So that is going to be our range. Okay, so for something like this, the domain is what x is allowed to be. And so with a rational expression, the denominator is not allowed to be 0. So that means that x squared plus 5 is not allowed to be 0, which means if I subtract 5 from both sides, that x squared is not allowed to be -5. There is no restriction on x. X squared will never be a negative number, because x is a real number, and if you square a real number, you either get a positive number or the number 0. 0 squared is 0. If you square a negative number, the negative sign goes away. So this will never happen. So it doesn't matter what x is. There's no restriction on x. Now, if this problem had been that, there would be a restriction on x, because x would not be allowed to be the square root of 5 or the negative of the square root of 5, because then when you square those, you get 5 minus 5, which is 0. But that's not the problem here. So don't confuse it with this problem. This one does have restrictions. That one doesn't. There's no restriction on x. Okay. Well, let's go back. Okay, so here, unmistakably, that is the multiplication sign. So f times g evaluated at x is just going to be the formula for f times the formula for g. And so none of these are like this, so you're going to have to FOIL it. And those will give you plus 66x and then minus 20. So the answer to 5 is A. Now, number 6, you have to be extremely careful, mainly because if you don't apply the negative sign to everything in G, your answer is going to be wrong. So f minus g evaluated at x is the formula for f minus the formula for g. Now, the parentheses don't matter in the first part, so you can drop them, but they certainly matter in the second part. So minus 2x, and then minus positive 3, so minus 3. And the most common mistake students make is they only apply the negative sign to the first term of g and not to every term of g. And then 10 minus 3 is 7. So most common mistake people make is they think it's 10 plus 3 and they get a plus 13 on there, but that's not the answer. So number 6 is D. All right, now you need to find a formula for F composed with G. This is obviously the composition symbol, not the multiplication symbol. F composed with G is the first one evaluated at the second one. And I have a formula for G. So now I'm going to take that and just write it without the X, because now I want to evaluate it at square root of X plus 3. And here the parentheses don't make any difference in the bottom, we just get that. So that's my formula for F composed with G. So these two here are the formulas you get there if you just do F times G, which from the symbol, it is not multiplication, it's composition. So I'm down to A and D. Now, if you have a square root as the denominator, then the argument is strictly greater than 0. So for here, we want X plus 3 to be strictly greater than 0. Subtract 3 from both sides, and the restriction on X is strictly greater than negative 3. So we start at, but we do not include negative 3, and then everything to the right. So that's going to be this one. Okay, now notice the only difference here is the symbol. The square bracket is, you would have included negative 3. So the answer to 7 is D. All right, same kind of thing. This, put it on. Okay. Now again, the symbol is composition, not multiplication. And F composed with G is the first one evaluated at the second one. So instead of G of X, we have X plus 7. So F evaluated at X plus 7. Write it without the X and just have parentheses instead of X. And I want it evaluated at X plus 7. And the parentheses don't matter here. So this is what my formula for F composed with G is. Now, if you have a logarithm, then the argument for the logarithm, what's inside the parentheses, is always strictly greater than 0. You cannot take a logarithm of something negative. You cannot take a logarithm of 0. So our argument here is X plus 2. So that is strictly greater than 0. Subtract 2 from both sides. X is strictly greater than negative 2. So again, if you get it memorized the wrong way and think it's greater than or equal to 0 for a logarithm, which it's not, that's going to lead you to the wrong choice, which would be D. So number 8 is B. Okay, let's go back. All right, number 9. They want the formula. And again, this is composition, not multiplication. So it's the first one evaluated at the second one. And G of X is X squared plus 9. So we're going to write that without the X, just blank parentheses. and we want to put x squared plus 9 inside there. And now I can drop those parentheses, and I'll get x squared plus 3 inside the square root. Now, don't ruin it and think you can simplify it more. You cannot. So remember, if you have a square root of a product, you can break it up like that when u and v are positive. But if you have a square root of a sum, you cannot do that. You cannot. So this here will not simplify any further. Okay, so trying to break that up, square root of x squared, which you might think, oh, that's x, and then plus square root of 3, that leads you to the wrong selection. Okay. All right. So the answer to number 9 is B. Number 10, you want to find f composed with g evaluated at 9. So it's the first one evaluated at the second one evaluated at 9. So you need to get g evaluated at 9 first. So that's the square root of 5 plus 9, which is the square root of 14. So I come back here, and this will be f evaluated at the square root of 14. So I come here, and f evaluated at the square root of 14 is going to be, wherever there's an x, you replace it with the square root of 14. And that's going to be my answer. And there it is. So the answer to number 10 is C. All right, so what you're going to need to do is you have this function, and they want to know what the graph of the inverse looks like. So you're going to need to get the graph of f. And the graph of f, and if f is 1 to 1, the graph of f and its inverse are symmetric with respect to the line y equals x. So if your graph looks something like that, then the graph of the inverse is going to be symmetric with respect to this diagonal line I've drawn here. Something like that. So you can tilt your tablet or your paper to where this line is vertical, and they should be mirror reflections of each other. It's always the way to tell. Okay, so let's get this in our calculator. All right, so I've got the square root of 3x plus 11, and then minus 2. Now, I'm going to go to my window, and I want the same window that they're using for these answers. So x-min will be from -5 to 5, and the y-min is going to be from -5 to 5, min to max. And then I'm going to do a zoom 5 because I want this to be square. So let's see if it will. Here we go. Now, that's this function here. So let's get the line y equals x. And just press graph. So I want my inverse to be symmetric with respect to this line. And you can try and do it by eyeballing it, or I'll go this our way. Like I said, if you're holding a graphing calculator, you can turn it on its side. All right, so let me. So what is its inverse going to look like? Well, if that vertical line now is a mirror, this part, this reflection is going to look something like that. And then this part reflected is going to look something like that. Okay. And now let me take a screenshot of it. And let me make this smaller. So I just need to tilt it the other way. Okay. So what I've drawn in red there should be what my inverse looks like. Let me get over here. Now am I going to be able to have it back here? All right, I can't impose it on here, but if we go back here, all right, I need to pick the one that looks like what I've drawn here in red. And it's not going to be A, it's not going to be B, it's going to be C. C is the only one that looks like what I drew in red. Okay, so what I drew in red looks like this one here. So that's the inverse. The inverse is C. And there is one like this on your midterm. Okay. I don't know if both of the midterms have it, but there's definitely one like that. Okay. Now, you could either be asked which is one-to-one or which has an inverse. They're both the same question. So you use the horizontal line test. This fails the horizontal line test because it intersects the graph more than once, a horizontal line. This fails the horizontal line test. This clearly fails the horizontal line test. This one does not fail the horizontal line test. It passes the horizontal line test. Any horizontal line I care to draw is only going to intersect that at most once. Okay. So the answer is going to be D. All right, now this is the graph of F. You've been given the graph of F. So this is the graph of F, and the points here are on F. Now, what F does is it maps the x coordinate into the y coordinate. Obviously, from the graph here, it passes the horizontal line test. F inverse exists. If you have points on F, what F inverse does is it maps the y into the x. So you've been asked to find F inverse of -2. You need to find the point with y coordinate of -2, because that's where F inverse will be mapped, because all of these points here are on F. So here's my y, and there's the point whose y coordinate is -2, and that is the point 0, -2. So 0, -2 is on F. So F of 0 is -2. F inverse of -2 is 0. So the answer is 0. So the answer to 13 is B. All right, now we need a formula. Okay, f equals 4x cubed plus 15 is a one-to-one function because it's the cubed function, which is one-to-one. Then you stretch it by 4, it's still one-to-one, and then move it vertically 15, it's still one-to-one. So it will have an inverse. So what are the steps? You start with this and you replace f of x with y. Then you swap x and y. Then you solve for y, i.e. you want to get y by itself on the left-hand side. And what you have over here is x's, numbers, and symbols, but not the plus or minus symbol. So let's swap sides. Let's subtract 15 from both sides. Let's divide both sides by 4. And now I do not have y by itself. I have y cubed. To get y by itself, I'm going to need to take cubed roots of both sides. When you take an odd root of both sides, you only get one possibility. When you take even roots, like a square root, you get plus or minus. But now the cubed root of y cubed is just y. And once I have solved for y, once I have y by itself on the left-hand side, I'm done. I replace y with f inverse. And so my answer is B. Okay, so they charge a monthly service. And the question here is, what is the monthly charge for a customer who uses 65 therms? Okay, so first of all, we have the monthly service of $12. Then, in addition, the customer pays $0.283 per therm for the first 85 therms. So if you're using 65 therms, we'll be in there. And then you pay that for anything over 85 therms. Well, we didn't go over 85 therms. If this had been 95 therms, that would have been different. But they want to know the monthly charge for a customer who uses 65 therms. So we're done. We didn't need this because we didn't go over 85 therms. Now, your question on this year's final, it could be like, what's the charge for a customer who uses 95 therms? It may or may not go over. So this is just, these are randomly generated, but this will be my answer. So now I just put that in my calculator. And we are going to get 12 plus 0.283 times 65. And all of these are taken to 2 decimal places. So if I take this answer to 2 decimal places, it's $30.40. So the answer to number 15 is A. Which of the following functions is odd? Well, look at them in your graphing calculator. Now, the graph of an odd function, you turn it upside down, and it will be exactly the same. Exactly. So you have to be careful because something like this, if you turn it upside down, it's got the same shape, but it's not exactly the same because this intersects the y-axis above the x-axis. This intersects the y-axis below the x-axis. They're not exactly the same. They have the same shape, but they're not exactly the same graph. So when you put these in your graph, I'm thinking start with the bottom one because usually it's not going to be the first one. And if you put that bottom one in there first, so let's look at selection D. Let me clear out this old stuff. 7x cubed plus 9x. Start with a zoom 6. Okay. Oh, my x didn't, I'm trying to do this with the mouse. Let's do that again. Okay, now, if you turn this upside down, because you'll have a calculator, you do get the same thing. But to see it, you can adjust the window. Let's just do from -2 to 2 for your x values. Okay, you should be able to see if you take this and turn it upside down, you're going to get exactly the same picture. So if I take this and I turn it upside down, is it going to let me? Just doesn't seem to want me to rotate. If you take that and turn it upside down, over here, I can do it here. There. You get exactly the same graph. So that is an odd function. Of course, there's only going to be one odd function in there, and that will be, so the answer to 16 is D. All right, so let's look at number 17. It's a piecewise function and find h evaluated at 1. So that's your x value. So if x is equal to 1, well, 1 is not between -5 and -1, so we're not using that formula. But if I replace x with 1 here, 1 is a number that's between -1 and +2. It lives in here, and even with the equal sign, it is -1 is less than or equal to 1, which is strictly less than 2. So, and 1 doesn't live in here. So the formula that we're using is x minus 4. And so h evaluated at 1 is going to be 1 minus 4, which is -3. And so the answer to that one is B. Okay. Now, what does it do when you multiply the outside of a function by a number? So if I'm multiplying the outside of a function by a number, then if x comma y is a point on the function f, on the graph of f, only the y coordinate gets multiplied by the number outside. So we're going to take a point on the graph, and it's going to be changed to -1/5 times y. Only the y coordinate will be changed. Now let's get some points that are easy to identify. Okay, so I've got -1 comma -1, this one here, then 0 comma 0, then 1 comma 1. So they'll have new points. The x coordinates stay the same. The x coordinates are unchanged. But I'll have a new y coordinate. So -1/5 times -1 is +1/5. -1/5 times 0 is still 0. And -1/5 times 1 is going to be -1/5. So what I've done in red, those are going to be my new points. And those points have to be on the graph. So of the function that we've been asked for. So let's look at these selections. Okay, so -1 comma positive 1/5. That is about there. 0, 0, and 1 comma negative 1/5. I have found it. Okay, and it's going to be that one. Let's show that the others can't be that. I need -1 comma positive 1/5. So it's not going to be this one. -1 comma positive 1/5. It's not going to be that one. -1 comma positive 1/5. This is -1 positive 5. So the only thing it could be is A. All right, now what does it mean for a graph to be even? A graph is even if it is symmetric with respect to the y-axis. So the y-axis acts like a mirror. So you can start on either side, it doesn't matter. So if the y-axis is a mirror, then this part, its reflection would be that, and that's not what we have here. This is good because if this half is looking into the mirror, its reflection is going to be what you see there. So the answer is going to be B, but I can go through the other ones. If this part is looking into a mirror and the y-axis is a mirror, its reflection is going to be, something like that, and that's not what you have there. And again, if and you can start on the other side. If this part is looking into a mirror, its reflection is going to look something like that, and that's not what you get with that one. So this is the only one that's symmetric with respect to the y-axis. The y-axis acts like a mirror. It's even. So the answer to number 19 is B. Okay, we have to remember what the rules are, the transformation rules, because there's nothing to put in your calculator. So if you change x inside the parentheses, if x gets changed to x plus 1 inside the parentheses, that is a left shift. And then if you subtract 1 outside of f of the parentheses, that's going down 1. So what we're going to do is this point starts here and we go left 1 and down 1. And so everything here will go left 1 and down 1. Left 1 and down 1. Left 1 and down 1. So the one that we want should look like that. Okay, so that's this one here. So the answer to number 20 is B. Okay, let's keep going. All right. Assume that the relationship is linear. So you're going to use linear regression. So we're going to put these in a list. Your x values, which are your first row, is going to be in list 1. And your y values, which is the second row, is going to be list 2. So just make sure you clear out any old lists. Second 1, comma, second 2. And I'm going to press stat, enter. And so I'm going to put my p-values in list 1. Then I'm going to come over here and put my d values which are my y values in list 2. Okay. Make sure everything looks right. You make a mistake here, everything's wrong. Okay. So I'm going to press Stat, go over to Calc, and then come down to Linear Regression, which is number 4, and tell it to use list 1 and list 2. And so you take your regression equation to 4 decimal places. Yes, the answers here are at 1 decimal place, but you only do that, only round at the end. If you take your regression equation to 1 decimal place, you're not going to get a selection that's even in there. So we have y equals ax plus b. So your y values are your d values, and a is negative 1.4276. We'll take it to 4 places, times x. Your x values are your p values. And b, I'm going to take that to 4 places. And now find the demand, find d, when the price, when p is equal to 15.4. So I'm going to put 15.4 into that equation. And then I'm going to take that answer and take it to 1 decimal place. So I'm going to have negative 1.4276 times 15.4 plus 57.4943. Okay. And then take it to 1 decimal place, which gives me 35.5. So that's about equal to 35.5. And you can see that's matching with selection D. All right. Now, for number 22, 9 is actually 3 squared, and if I rewrite this as 3 squared, I have the same base on both sides. And if you have the same base on both sides in a single expression, then the exponents are equal to each other. So 2 is equal to 2x minus 10. Add 10 to both sides and divide both sides by 2, and x is equal to 6. Your answer is D. Now, I cannot write 10 as a power of e. So I can't solve this the way I did in number 22 because I was able to rewrite 9 as a power of 3. So what I'm going to do on this one is I'm going to do the conversion. Now, if you have something in this form, you can convert it into logarithmic form. So this is my a, that's my y, and that's my x. And now go to black. And now, if the base is e, the shorthand is ln of 10. Now, we're meant to find x, and we have 6 times x. So divide both sides by 6. And so my exact answer for x is ln of 10 divided by 6. That's my exact answer. And I just need to put that into my calculator. Ln of 10 divided by 6. Ln of 10, close parentheses, divided by 6. And all of these answers are taken to 2 decimal places. If I take that to 2 decimal places, that's 0.38. And so the answer to number 23 is B. The answer is B. Okay, so for 24, I'm going to use the quotient rule for logarithms so I can get a single logarithm there and then do a conversion. So the quotient rule says this will be my numerator and the argument there will be my denominator. Now I can do the conversion. The base raised to this power is equal to whatever the argument is, whatever's inside the parentheses. And so that gives me 16 is equal to x plus 9 over x. Now here's where students just freak out. They don't know how to solve it for x. First of all, you cannot cancel. That doesn't cancel. Get rid of the fraction. How do you get rid of a fraction? You multiply whatever's in the bottom. Do it to both sides. So I have 16x is equal to, well, these now cancel. Subtract x from both sides. 16x minus x is 15x. And now divide both sides by 15. And we have our exact answer. It's just that 9/15 is not reduced. So you can do 9/15, then press the math button, then enter to give it in the lowest form. Or 9 is the same as 3 times 3. 15 is the same as 3 times 5. Now the 3's cancel because we have a product there. And x is equal to 3/5. 3/5. So the answer to 24 is A. Okay, so you notice here, number 25, you have not been given the formula. You have to know the formulas. So we've been told it's compounded quarterly. So we're going to need the formula, or it's compounded n times a year. So we have n is equal to 4 because it's compounded quarterly. That's our starting amount. That tells me that r is 0.06 and t is equal to 8. And put it into your calculator exactly as it's written there. Do not work out the inside parenthesis first, because invariably what students will do is they work it out, then they round it, and they've introduced rounding error, and you've just missed the problem. Do the whole thing in one go. So 421 parentheses 1 plus 0.06 divided by 4, close parentheses, up arrow, parentheses, 4 times 8. Okay, now that's 32. Or you can do 4 times 8. It doesn't matter. Finally, this is the amount in money, in dollars and cents. And so you dollars and cents, that means you round to 2 places. And you're not told to round to 2 places because you should know that dollars and cents is rounded to 2 places. And there we are. Okay. All right. Let's go back here. All right. How many hours does it take for the original population to double? So find the time when the population after time t is double what you started with. What did you start with? That number out the front is always your starting amount. Now here we have a formula for n of t. And here we have a formula for n of t that we got from this sentence. They're both equal to the same thing, so put them equal to each other. Now, you can divide both sides by 167. The 167s just cancel. This is why I didn't multiply it through. You want to solve for t, and t is in the exponent. So take logarithms of both sides and use the power rule to get the t out of the exponent. Now, what base are you going to use? The base here is e, so take ln of both sides. So we're going to have ln of 2 is equal to, now the power rule says if you have a logarithm of something to a power, it comes out the front. But ln of e is just equal to the number 1. That's why we took ln, since this had base e. We're meant to find t. I have 0.072 times t. So divide both sides by 0.072. So once you cancel, this is exactly how much time it will take. And so that's what you put in your calculator. ln of 2 divided by 0.072. Okay, and they're all taken to 2 decimal places, and we can see here that that's 9.63. So the answer is C. The answer to 26 is C. Okay, let's come to this one. This is just a logarithm problem. So we have an equation. Now we're used to seeing logarithm equations where the log is out the front. So let's swap sides. Okay, so that's all I've done to that is swap the sides. And this wants us to, what is the hydrogen ion concentration? Well, that's H. So we're supposed to find H when the pH is equal to 4. So I can refine this equation. This equation now becomes this. Now I can do a conversion. I can use my conversion formula, but only if there's nothing out the front. Now how do I get rid of that negative sign? And this is where students will just freeze. What would you do to get rid of that negative sign if you just had h multiplied by a number? Well, you'd divide both sides by -1 or multiply both sides by -1. But stick a log in there and students just don't know what to do. So I'm going to get rid of that negative sign. I'm going to multiply both sides by -1. Or I'm going to divide both sides by -1. But I'm going to get this. Now, if it's log and nothing written there, what is the base? The base is 10. Now we're going to do the conversion because we've been told to find h. The conversion formula says the base raised to this power is equal to the argument. So find h. I have found h. It's 10 to the -4th. The answer is A. The answer to 27 is A. Okay. All right. Now, divide this polynomial by x minus 5. So we're going to use synthetic division. Now, it's x minus the number in the box. So 5 goes in the box, not negative 5. If you put negative 5, it's going to take you straight to the wrong answer. Then we use the coefficients here. 1, 4, 4, and 4. 1 times the number in the box, then we add. 9 times the number in the box, then we add. And 49 times 5. That looks like 245. And then add these. Now I'm done with my synthetic division. This is my remainder. And these are the coefficients of the quotient. If I start at the line, that's my constant, that's my coefficient for x, that's my coefficient for x squared. That means I can write p of x as the divisor times the quotient plus the remainder. The divisor is what you divided by, or x minus the number in the box, times the quotient. So 1 times x squared plus 9x plus 49 plus the remainder. Now, none of these look like this. This is not correct. It's x minus 5 times x squared plus 9x plus 49. None of these look like this. Well, there's a second way you could write this. You can write p of x like this, or you can write p of x divided by 5 using this form. So if I divide p of x by x minus 5, then every term here gets divided by x minus 5. So p of x divided by x minus 5, the x minus 5s will cancel there. And then I have this, which cannot be reduced. And so that's what I'm looking for. And that's the one that we have there. So the answer to 28 is A. All right. Now, students will miss number 29 because they get the essential numbers they need to look for backwards. So, I'm going to make a list of all possible rational zeros. So the list is going to be plus or minus a fraction, and in the numerator, it's going to be all factors of 9, and in the denominator, it's going to be all factors of 11. And most students will get the 11 and the 9 swapped around to where they're the 11's in the numerator and the 9's in the denominator. So my list is going to be all possible fractions you can make using the factors of 9 and the factors of 11. So if my denominator is 1, I'm going to get 1 over 1, 3 over 1, and 9 over 1. Then if my denominator is 11, I'm going to get 1 over 11, 3 over 11, and 9 over 11. And plus or minus. So 3/11 is in the list. So I'm done. But let's go through. 11/3 is not in the list. 0 is not in the list. And 12/11 is nowhere in the list. So nobody asked you what the actual 0 is. So 3/11 may or may not be an actual 0. You were asked what is the possible, and the rational zeros theorem gives you a possible one. And these were impossible. They're not on our list of possibilities. This was on the list of possibilities. possibilities only. So it could be a 0 or it might not be. So you were not asked the actual ones. So this is not one you can answer with your calculator and look for x-intercepts, because they're just asking you for a possible one. Okay. Number 30. This is one you do need your calculator for. So put this in your calculator and look for x-intercepts. And if you get an x-intercept, you'll have a 0. Clear that out, and let's put x cubed minus 4x squared minus 3x plus 12. I'm going to start with a zoom 6. Okay, I might refine that a bit. I might click on window, and let's look from -5 to 5. Okay, we definitely have 1, 2, 3, 4. We definitely have an x-intercept at 4. There is no x-intercept at -4. So it can't be that. We do not have an x-intercept at 3. So it can't be that. And there are 3 x-intercepts. This is saying there's only one. And this makes sense because where is the square root of 3? It's about 1.7 something. So between 1 and 2, but closer to 2. And where is the negative square root of 3? It would be between -1 and -2 and closer to -2. So we can tell from our graph, we can certainly rule out these other possibilities. You get a 0 when you get an x-intercept. You get a real 0. So the answer to this one is B. The answer to 30 is B. Okay, so now let's look at this next one. Which of these must be true? Okay. Well, let's see what the zeros are. So if you set that equal to the number 0, then x itself is 0, will make the whole thing 0. If x is -6, it'll make what's inside this parenthesis 0, make the whole thing 0. If x is 6, and if x is 8, it'll make the whole thing 0. So these are the zeros. And be very careful. Polynomial has 0, 0, 6, -6. That is not a 0. So this statement is false. So we know that statement is false. The polynomial has degree 6. It does not have degree 6 because you have x to the first times x cubed times x cubed, so for your leading term, times x. So that's your leading term, a times those powers of x, which is going to be a times x to the 1 plus 3 plus 3 plus 1. So it has degree 8, does not have degree 6. You have no way of knowing what a is. So by process of elimination, it's going to be C. The graph of the polynomial crosses the x-axis at x equals 6. Now, what happens at 6? We have a 0 of 6, and its multiplicity is 3. If a 0 has odd multiplicity, it crosses through. So this is true. It crosses the x-axis at x equals 6. So the answer to 31 is C. Find all the zeros. Again, this is one you're going to want to put in your calculator. Do that. me get rid of that, and we do 9x cubed minus 81x squared plus 191x minus 119. Just eyeball that and make sure I didn't make it. I'm going to start with a zoom 6. Okay, so first of all, there are no negative x-intercepts. So I will not have any negative real zeros. So -1 is not an x-intercept. So it's not going to be C, and it's not going to be A. And now let's just zoom in on this a bit. Okay, so I've got 1. I have an x-intercept at 1, so I have a 0 at 1. And then we've got 7/3. So this is where 2 is. 7/3 is a little bit bigger than 2. Okay, so that agrees with that. 3/7, that's not right. Where is 3/7? 3/7 is between 0 and 1, and I don't have an x-intercept between 0 and 1. And same thing, ditto for 3/17. I don't have multiple x-intercepts there. And 17/3, that's going to be a bit more than 5. 5 2/3, which is where we'd expect that to be. So that's going to be our correct answer. So x-intercepts are the same as real zeros, and these are 3 real zeros that match up with the graph. So the answer to 32 is D. Okay, you have to know the rules. If you don't know the rules, there's nothing to put in your calculator. Okay, so you can clearly see from this picture the end behavior is down, down. If the end behavior is down, down, then the leading term, there's a chart and there's 4 cases. If the end behavior is down, down, the leading term is a negative number times x to an even power. So that means your degree is an even number and your leading coefficient is negative. So the degree is even and leading coefficient is negative. The answer is C. The only way you get that right is to know the chart, the 4 cases. Otherwise, you're guessing. It's easy if you know the 4 cases. All right, which accurately suggests the end behavior and any other important characteristics of the graph, which could be the graph of a polynomial function? Well, it can only be D. This is like a cubed function, but it's been shifted. This cannot be a polynomial function because the domain is 0 to infinity. Polynomial functions have domain -infinity to infinity. And see, this is going to keep going like that forever. And that's slow. It's going to get wider and wider forever and ever. So it has the correct domain. This doesn't have the right domain because it actually is inhibited there by an asymptote. It looks like it has a horizontal asymptote too. This has a sharp pointy bit, so that's not a polynomial function. So this is our polynomial function there. So it's just the cubed function, f of x equals x cubed, shifted up 1 and then to the right 4. All right, use a graphing utility to approximate the real zero. All right, so what we're going to do is we're going to get our calculator up. And okay, let's get that back up there. I have a little room now. Okay, that's better. Okay, I'm going to clear that. Now we're going to put this one in, 4x cubed plus 7x squared plus 5x plus 3. And we'll start with a zoom 6. Okay, so it looks to be close to -1. All of those look to be close to -1. So I'm going to do second and the trace button, and I'm going to scroll down here to 0 and press enter, and it wants a left bound. So this flashing ball, I can only use left or right scroll. I'm going to scroll it till it's just to the left of where it passes through on the x-axis. That would be okay too. Enter. Then it wants a right bound, so I'm going to use my right scroll to scroll just to the right of where it is on the graph when it intercepts the x-axis. Then it says, do you want me to guess? Yes, I do. Press enter again. And it's going to tell me what it thinks the x-intercept is, which will be the 0. So it's telling me it thinks -1.229466. Now they're taking everything to 4 places. 1, 2, 3, 4. And so this is going to be, that's the one. So that's how you use your calculator to find that. And the only way you're going to get it is from your calculator. It's not at all obvious between those which it is, which one it's going to be. Okay. All right. What I'm going to do, this second equation is, this is nonlinear. You cannot use an augmented matrix to solve it. It does not work on nonlinear systems. I'm going to subtract 11x from both sides of this. Now, both of these are equal to y, so I'm going to set them equal to each other, which they are. Now, I can solve a quadratic if it equals to 0. So I'm going to subtract 9 from both sides, and I'm going to add 11x to both sides. So over here, I'm going to have 0, and I'm going to have x squared. X plus 11x is 12x. 44 minus 9 is 35. And now I can solve this either using quadratic formula or I can factor it. Two numbers that multiply to give me 35, but at the same time add up to give me 12, 7, and 5. So what will solve this if x is -7 or if x is equal to -5? So I have two cases, x is equal to -5 and x is equal to -7. So already that ain't happening. You can't have x is equal to 64. It's not a possibility. Ditto there. That's not a possibility. And this has got it to where, oh, my two answers are -5 and -7. No, the x coordinates of your solutions could be -5 or -7. So at this point, you should be able just to cross out C and circle B, but I'll take it to its full, to the bitter end, as they say. Let's go back to this equation because we subtracted 11x from both sides. And so we have that. And so I'm going to get y is equal to 9 minus 5 times 11 times -5. That's going to be 9 plus 55, which is 64. So this tells me I get an intersection point. Its x coordinate is -5. Its y coordinate is 64. And same thing here. I'm going to have minus 11 times -7, which is going to be 9 plus 77, which is 86. And so I get an intersection point. Its x coordinate is -7. Its y coordinate is 86. The answer is B. The answer to number 36 is B. All right, let's come to 37. This is going to be a linear equations, and you'll solve it with an augmented matrix. Okay, so we have apples and bananas, and they want to know the price of one banana. Some years they ask you what is the price of one apple. So we're going to let A be the price of an apple, and we're going to let B be the price of a banana. So this sentence gives you an equation. 4 times A plus 5 times B is equal to 5.82. This sentence gives you an equation, and it's 2 times A plus 9 times B equals 564. You have two linear equations. You have a system of linear equations. You've been doing this in your web work and in class with x and y. Now it's A and B. You can get an augmented matrix. You could also solve it using substitution or elimination, but since there's decimals there, let's use an augmented matrix to solve this. And we need to get this into row reduced echelon form. So let's get our matrix up here. Let's get out of that. Let's get into the matrix menu, go over to the editor. My augmented matrix is a 2 by 3. So I've got 4, 5, 5.82, then 2, 9, 5.64. Let me eyeball that and make sure it's correct. Okay, get out, second mode, get back in. Scroll over to math, go up to RREF, then get back into the matrix menu, and under names, just select A and close out the parenthesis. So this is my RREF matrix. So now we go back to a system. So that's where the equal sign is going to be. Before we were working with x and y, now we're working with A and B. So this first row tells me 1 times A plus 0 times B equals 0.93. The second row tells me 0 times A plus 1 times B equals 0.42. Now, we were asked, what is the price of a banana? So that's what we're looking for. If the question had been, what is the price of an apple? Then the answer would have been that one. So they change them from year to year. So make sure you pay attention. You might not necessarily be solving for banana, but it's the same amount of work. So the answer to the question that was asked that year is 37 is A. Okay, let's get back. Solve this system. Well, you have to put that into an augmented matrix and then see what you get. You'll either get a unique solution, no solution, or infinitely many solutions. Okay, so let's get our augmented matrix My augmented matrix is going to have 3 rows and 4 columns. So the first row is going to be the coefficients of the first equation. 1, 3, 1, 17. My second row is going to be the coefficients of the second equation. 7, 22, 10, then 116. And my third row is going to be the coefficients of my third equation there. 8, 25, 11, and 133. Now I'm going to get out. I'm going to get back in. I'm just going to look at this. And I'm just going to double check. Okay, yes, that's what we wanted. Now I want to get this matrix into row reduced echelon form. Get back into the matrix menu, go over to math, scroll up, then get back into the matrix menu. Under names, just press enter and close out the parenthesis. So what we have is when we get this into RREF, and straight away this tells me 0 equals 0, which means we have a dependent system. There'll be infinitely many solutions, and so you have to write the generator. And if you just look at the selections there, the only one written with the generator is C. There definitely is a solution. So what is the generator? So this is going to be our answer. But what is the generator? Well, the first row gives me the equation x plus 0 times y minus 8 times z is equal to 26. So the generator, instead of x, y, z, you have to write it in terms of z. So you keep the z. And so instead of x, well, take that and add 8x to both sides. 8z to both sides. So instead of x, you write 26 plus 8z there. You only use z's. And the second equation tells me 0 times x plus 1 times y plus 3 times z is equal to negative 3. And if you want to get y by itself, subtract 3z from both sides. And so now instead of y, you have an expression that only uses a z. And so you can see that's my generator. And you do that when you have infinitely many solutions. The answer to 38 is C. (39) Find f of 4. Okay, well, do numerator and denominator separately. So the numerator is going to be 4 cubed plus 2 times 4 squared plus 10 times 4 plus 7. Okay. Do numerator and denominator separately. So numerator, clear that, 4 cubed plus 2 times 4 squared plus 10 times 4, which we know is 40, but I'm just going to write it, plus 7. Then press enter, and we get 143. And the denominator is 17 times 4 squared plus 8 times 4 plus 1. Then press enter. We get 305. And you just want to make sure it's in lowest form. So now do 143 divided by 305 enter, and then do math, enter, enter. If it reduces, it'll show it to you in lowest form. It does not reduce. So now we can see, there we have it. Okay. Find any horizontal asymptote of the graph. You have to know the cases. The degree of the numerator is 2. The degree of the denominator is 3. If the degree of the numerator is smaller than the degree of the denominator, then the x-axis is the horizontal asymptote. Now, every year, it's not necessarily the numerator that's the smaller degree. So let me change this problem slightly. Let me change that. Now, what would the answer to that problem be? Now, the degree of the numerator is 3, and the degree of the denominator is 3. If the numerator and the denominator have the same degree, the horizontal asymptote starts life as a fraction, and it's going to be equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator in lowest form, and there's no reduction there. And so if that was the new problem, that would be the answer. And if this problem had been that, then this would have been the answer, because if the degree of the numerator is bigger than the degree of the denominator, there's no horizontal asymptote. So it's randomly generated every year to be one of those three. Find the vertical asymptote of the graph. Vertical asymptotes are found at the real zeros of the denominator after any cancellation. So there's no canceling because 15x squared plus 1 doesn't factor. And what will make the denominator 0? If x is 10 and if x is 12. So we have two vertical asymptotes. Their equations are x equals 10 and x equals 12. The answer is B. Okay, let's look at what these would be. I'm going to do red and blue. So to get y by itself, I need to subtract 5x from both sides and divide everything by 10. Subtracting 5x does not change the arrow. Dividing by 10 does not change the arrow. I'm not going to reduce because I'm just going to put that in my calculator as it is. So I'm going to look at -5 minus 5x, close parentheses, divided by 10. And I'm going to make my window the same size as this window, going from -5 to 5 for my x and y. And then I'm going to press graph. Okay. So I want the line. It's less than or equal. I want the line and everything below it. So that's the first region. Now my answer is going to be the overlap. Now, where is my second graph? Okay. Here, to get y by itself, I need to add 4x to both sides and then divide everything by positive 10. And that does not change the arrow. Adding 4x and then dividing everything by positive 10 does not change the arrow. I'm going to come here and go down to the next line, and in parentheses, -10 plus 4x, close parentheses, divided by 10. I'm not going to do any reduction because it's going to be, and just going to press graph. So here, I want the line It's greater than or equal to and everything above. So I want the line, oh, it needs to be blue. I want the line and everything above. And my answer is going to be the overlap. And we should be able to see now the overlap is this region here. So that's what I'm looking for. And which answer looks like that? Well, not A, not B. It's going to be C. It matches the overlap region. So the answer to that is C. 43. Okay, now this tells you that you are restricted to quadrant 1. This is not restricted to quadrant 1. So being restricted to quadrant 1 means just in here. And so it cannot be B. So that restricts us to quadrant 1. Now, the line y equals 3 is a horizontal line going through 3. And this here tells us we want the line, so it's going to be on and below. But we want to be restricted to quadrant 1. So I might do that in red. So on and below. So it cannot be A because the shaded region you're seeing there is part of the on and above. So it can't be A. Right. And then I'm going to do this one in blue. If I subtract x from both sides, it doesn't change the arrow. And so we want on and below that line. And that line's going to look something like that. And we want on and below this line inside the first quadrant. I'm sorry. Inside the first quadrant. Only inside the first quadrant. Now, where's the overlap of red and blue? This purple bit here. So now let me get rid of the colors. I still want these lines. And my answer is going to be this part. We have that in black. I want this. This region here is my overlap. So let's see which one that is. And it matches C. So the answer is going to be C. Okay, so let's come to this one. We're talking about hammers and pliers. You cannot have a negative number of hammers and pliers. And so from the get-go, you have to have your number of hammers has to be at the very least 0. Ditto for pliers. This has to be part of your system. And it's not in this first system here. So it's not going to be that one. Now I'm going to color code the rest of them. A hammer requires plastic. So I'm going to do plastic in red. So they both require plastic. They both require steel. And they both require labor. So with a hammer has to have 10 ounces of plastic. With a pair of pliers, they have to have 4 ounces of plastic. Each week, there's only 1,700 ounces of plastic available. So we get an inequality. So for the hammer, 10 times ounces for every hammer, plus 4 ounces of plastic for every pair of pliers. There is only 17,000 ounces available, so this number cannot go over 17,000. So that has to be our first equation, and you can see here that's not right. So we can rule out B because of that one. And you can't see the other ones, but we will in a minute. Okay, so now let's go to steel. A hammer requires 9 pounds of steel, and a pair of pliers requires 1.2 pounds of steel, and there's only that much steel available. So we have a new inequality. So 9 pounds of steel for every hammer, plus 1.2 pounds of steel for every pair of pliers. It cannot go over 14.5 because that's all there is available, all the steel that's available. And then finally, for labor, each hammer requires 6 minutes of labor. Each pair of pliers requires 8 minutes, and they only have enough employees every week for 16,900. So 6 minutes of labor for every hammer, plus 8 minutes of labor for every pair of pliers. It cannot go over 16,900. That's all that's available. And so that's our system. So this is our system, and of course we want those in there as well. And so now if I just scroll this up, that's going to match this one. You can see those arrows are not pointing the right way because this is all that's available, so you can't go over that. So the answer is C. Okay, here again, this alone tells us we are limited, restricted to the first quadrant. And we have 2 lines here, and it doesn't look like we will have an arrow change. So to get y by itself, I subtract 12x from both sides, and then divide both sides by 6. And to get y by itself, and so no arrow change. To get y by itself, I subtract 2x, and then divide both sides by 6. No arrow change. So you're going to have, let me put these in the calculator. Get rid of those. So now I'm going to have parentheses 174 minus 12x, close parentheses, all over 6. And I'm not going to reduce it because I'm going to get the same line regardless of whether or not I reduce it. Parentheses 64 minus 2x. Close parentheses divided by 6. So let's change this window because I'm only interested in the first quadrant. I might take my x max to 30 and my y max to 30. Let's see. Okay, I'm going to have 2 lines, and they're going to look something like that. All right, so both of these are on and under. So it really doesn't even matter which one is which. Both of them are going to be on and under. So it doesn't matter what colorings I use. Both of them are on and under in the first quadrant. Limited to the first quadrant. And then the second one, on and under, limited, on and under, limited to the first quadrant. So where is the overlap? You can see where the overlap is. This is the overlap. How many corner points are in this figure? So this is our overlap. And how many corner points do we have? We only have 4 corner points. 1, 2, 3, and 4. This has 4 corner points. It's still in the running. This has 1, 2, 3, 4, 5 corner points. Our figure does not have 5 corner points. This has 1, 2, 3, 4, 5, 6 corner points. Can't be that one. This has 1, 2, 3 corner points. So we did not have to find the corner points because of this. The only thing it can be is A. What is A plus B? You can only add or subtract matrices if they have the same dimensions. A is a 3 by 3, B is a 3 by 3. You will get a 3 by 3. Now, pick an entry at random, the top left corner. What is that going to be? It's going to be the top left corner of this one plus the top left corner of that one. Which one has -8? And it can't be this. It can't be that. And you're going to find it's going to be this one. If you just add corresponding entries, everything checks out, and it's quicker than putting it in your calculator. All right, what is A times B? You don't need to put this in your calculator. A is a 3 by 3. B has 1, 2, 3 rows and 2 columns. Now, is this defined? Look at the inside numbers. They're the same. Yes, it is defined. And what are you going to get? You're going to get the outside numbers, a 3 by 2. This is a 3 by 3. It can't be that. This is a 1, 2, 3 rows and 2 columns. So that's in the running. But this is a 2 by 3. It cannot be that. So the only thing it can be is that. You did not have to put that in your calculator. If you take a matrix and multiply it by a number, then every entry in A gets multiplied by 3. So again, let's pick one that's different if we can. All right, well, so 3 times A will also be a 3 by 3. And so what's that one going to be? Well, if I take this and multiply it by 3, so I'm going to have -12 in the top left corner. So it cannot be that one. And what is that one going to be? It's going to be -7 times 3, which is -21. That's not -21. And so this is the only one that's going to work. You take every entry and multiply it by 3. So the answer to number 48 is A. Didn't need to do that in a calculator. Okay. All this is doing is telling you that A inverse exists. So A inverse exists. So they want you to solve this matrix equation, and I'm going to call that capital B. And all you do is you multiply A inverse on the left-hand side of each of these. So that's the formula you have to remember. So you define A in your calculator, you define B in your calculator, and get your calculator to do that. So let's do that. Get into the matrix menu. A is a 3 by 3. So A is going to be negative 21, 8, negative 9, 16, negative 6, 7, then 3, negative 1, 1. And just eyeball that, make sure I've done that right. Get out, get back in, go over to the editor, and now scroll down to B. B is a 3 by 1. And it will be negative 8, 6, negative 8. Get out, and now ask it to do A inverse times B. So get back in, choose A, then click the X inverse button, then times, get back into the matrix menu, and under name scroll down to B, and now click enter. And so that is our answer. That's what X is equal to. And so we have solved this. This one right here. And finally, find A inverse, put A into your calculator and ask it to do A inverse. Over here. So this is one where you do need to use your calculator. So get into the, try it again, get into the matrix menu, second, X inverse, go over to the editor. A is a 3 by 3. So we're going to have 8, 1, 5, negative 17, negative 14, 2, 3, 4, negative 2. Get out. I might get back in and then under names just press enter, and I'm going to have a look at that and make sure I put it in correctly. That's great. So now get back in, choose A, then click X inverse, press enter. And now we want to do math enter enter, math enter enter, because I want these as fractions. And so this is telling me that my first column is going to be 10, negative 14, and negative 13, and that should be enough to say it's going to be C. But then we have 11, negative 31 halves, negative 29 halves, and then I can come here and I can scroll. Okay, and 36. And then negative 50.5, it's the same as negative 101.2. I don't know why it didn't change it into a fraction. It just, if it's 0.5, big numbers like that, sometimes it doesn't. And negative 95 halves is the same as negative 47. Yeah, okay, and so definitely A inverse exists. If it didn't, you'd get an error message. So there's clearly the only choice is C. In those. Okay, so that completes the final. And so I've been explaining myself through it, but it did take me, I almost used the entire 2 hours of time. So just make sure that you do enough of these to where you're confident and you're not going to be wasting a lot of time on them. So I'm going to stop the video there.